Okay, if you missed this first bell work, too bad. Go do it. It takes a while. But for our second one, we'll do together. Okay. Yep. Pedro, what do I do? Oh, you got the answer. Okay, so what do I need to do first?
Find cos of pi 3 over 3, which is just cos of pi.
Right. So what I'm going to do is I'm just going to plug it in. I don't need to worry about simplifying because cosine is defined everywhere and exponentials are defined everywhere.
Why did you put in 3?
Because x approaches 3. Right? X is approaching 3. So then I have e cubed cosine of pi. And what is cosine of pi? Minus 1. So therefore, it is negative e cubed. Yeah, because remember, cosine of 0 is 1. Cosine of pi on the other side is negative 1. There we go. Do we all feel great about that? Who says no? Matthias? Okay, so the trick you just have to remember is how to do the unit circle bud, that's all. Start by plugging it in, and then realize the 3's cancel. Cosine of pi, you look it up if you don't remember, but it's negative 1 if you look it up on the unit circle, okay? Negative 1? Negative e cubed? All right, because technically, you guys, what is it? It's technically actually this. E cubed times negative 1. I bet you if you write it this way, someone's going to write, oh, it's e cubed minus 1. That's wrong, because they're multiplied, right? So what I do is I always move the coefficients to the front. That's how I go. Okay, so remember back in geometry when you didn't learn about commutative property? Exactly. I said, remember back in geometry when you didn't learn about commutative property where you were supposed to? Commutative property, you know it even though you don't know the name. Guys, what's 2 times 3? What's 3 times 2? Did the order matter? That's commutative property. So because these are multiplied, I can write them in whichever order I want. Put the number first, you'll make less mistakes. Does that make sense? It's not wrong to put it this way, but if I didn't have the brackets, now it's wrong. Okay. Let's learn some properties of limits. Are you ready? All right, guys. I think you already know these because we did them. Listen up. Listen up. Listen up, guys. So we did these on the very, very first lesson, I believe. Okay, I just didn't tell you that we were doing them. So let's see if you remember them. If I was adding 2 limits, that was exactly the same as me simply just taking the limit of f of x and adding it to the limit of g of x. Which means that if the limit of f of x is L and the limit of g of x is m, this is literally just going to be L plus m. Like if I'm saying L and m are the answers, right? I'm going to write it out the long way, and I suggest you do too, just so you can look back on it if you need to. If I'm subtracting them, exactly, I'm going to eventually get to there. Let's go ahead and write out the full thing though, just so that if we ever need to, we can look back on it. So the limit of f of x minus the limit of g of x is going to be L minus m. Is everybody understanding that so far at least? Like I said, remember we did this in the very first lesson? Yes. Right? We did. I didn't tell you these were the properties, but we kind of said, what do you think it would be? And you all guessed right. It's because the limits aren't, or the properties of limits aren't that hard. All right, if I'm dividing them, what did we do? I just divide them. So it's the limit of f of x over the limit. Technically, the limit as x approaches a of g of x, which is going to be L over m. See how smart you guys are? I mean, fill out your pass.
This is my favorite.
Yes, but I know that you're one of the ones that told Valentine that I don't use the passes, and that's not true. I tell you to do it. If you choose not to do it, that's your fault.
You really think I tell that to Valentine?
Yes, I absolutely think you would try to throw me under the bus to save yourself. I 100% believe that.
How can you say that?
Anyway, you can go, buddy. Yeah. I am working on getting an iPad, okay? He's tested it out. He's got one ordered for me. We will have an iPad soon, hopefully. I'm just going to mount one on the wall so you guys can fill out a smart pass to go to the bathroom. Yeah. All right, so if I multiply, you guys, we already did this too. That just meant that I found the 2 limits. And I multiply them by each other. So I'm simply multiplying these two limits. So this is going to be, L times M. Or if you prefer, you could literally just write LM. Right, you don't have to put the multiplication or the dot
So we put parentheses.
if you want to.
Okay.
Means the same thing. All right, so then if we multiplied by a constant, which we did several times, what did that mean?
CO.
So maybe actually, you know what? Let's instead of writing it, let's write it this way: C times the limit as x approaches a of f of x, which is really just CL.
These are not.
I know, isn't it great? Nice and easy. Don't you all feel super smart right now? Matthias, did you say no? Matthias, don't believe that lie. You are a smart individual. Okay. We didn't do this one, but what do you think it means? It is going to be that. So let's write it out fully. So it is the limit as x approaches a of f of x. You can think of it as being like a big set of brackets to the power of p, which of course in our case is going to be L to the power of p. And this one, I don't remember if we did this, but what do you think the limit of a constant is? It's the constant. Yeah, it's literally just the constant, right? Because think about it. What is a constant if you pictured a graph of a constant? What is it? It's not a dot. That would be different. That's a point. A line, but it would be a horizontal line, right? It'd be like y equals 4. What's the slope of a horizontal line?
0.
0. And what is like, anywhere I look upon this line, what would it be? None. Now it would be 4, exactly, right? So the slope of it is 0, meaning it's not changing, which means no matter where I look upon this thing, it's 4. Did I confuse you with the slope part? Forget the slope part. Just think about the fact that it's 4 everywhere, okay?
It's my favorite thing.
I know. Well, we're going to now apply them. So we are going to keep doing them, but we'll apply. So if I have these two limits, and I have my two graphs, I can just find each limit and add them together, right? So remember, these are one-sided limits. So the limit as x approaches 2 from the left of f of x, from the left would be up here, it's 3. Right? Do you guys all see that it's 3? Because it's only the one-sided limit. For g of x, as I approach 2, it's 1. So the answer is just going to be 3 plus 1. We get to do some basic, like, grade 1 math. It feels great, right? We got to do some calculus first, but then we get to do grade 1 math. All right, so here, I'm going to find the limit as x approaches -1. It's not one-sided, so it's from both sides. So -1 here, that's the bottom of this vertex. Exactly, but it is going to be 2 times that, so let's write that out for now. And then this one's going to be 3 times the answer to g of x. So the limit as x approaches -1 of g of x
1.
is -1. It is, you're right. Right? And it's just approaching that dot that's there. I don't know why there's a dot, but there is. And so then I just multiply these things all together. So I'm going to get -12 minus -3, which is the same as plus 3. So it's -9.
But it's -3 or just minus?
It's minus -3. Like it's because it's -3, -1. So you can think of that as plus 3, right? If you're subtracting a negative, that's like adding a positive. When I used to teach that in middle school, I had this great comic strip that I had in my classroom about this like negative monster and beautiful positive flower, and how the monsters would kill themselves when they fought each other and become a flower. It was really weird and dumb, but every single one of my middle schoolers would remember that 2 negatives made a positive. None of them ever forgot it because of this stupid comic that I made. I even illustrated it. It was great. It was great. I had it like at the top. Anyways, okay. The limit as x approaches -3 from both sides of f of x. -3, oh, it exists here. This is -2. Minus, what about for g of x? As I approach -3, now, Pedro, it doesn't exist. And if one of them doesn't exist, exactly, I can't say -2 minus does not exist, so that means it just does not exist. Or 1, as you guys thought. Make sense? All right, and we're supposed to state the reason. Our reason's always the same. The left side does not equal the right side. Amazing. All right, do you guys need me to keep scrolling up and down, or can you look at your own page? Okay, good. Then I'll maybe do the same. I'll just put the graphs on one screen here. So we're going to approach 6. As I approach 6 from both sides, it's -4. So it'll be -2 times -4. You did not go to the bathroom. You came back with a cup. You didn't have that cup when you left.
No, I had this. They gave me this gift.
You literally went like shopping, man.
It had my name.
Where's my cup?
I can't. You want this? I swear I
No, I actually don't want it.
Please take it.
I don't want it. I don't like having a bunch of mugs. I usually just use my thermos one. All right, then g of x. So if we look at g of x for 6, yep, it's 6. So I'm going to get positive 8 over 6. Does that make sense? I think I might actually scroll up and down because the video is going to be hard for the rest of them if I don't do that. So they can think a little bit. All right. So what we're going to do here is we're going to do the limit as x approaches 4 of both. So as we approach 4, it's -3, right? You can see that here because it's just the continuous graph, so there's nothing I need to do. And if I look over here, it's this vertex, so it's 4. So -3 and 4. Everybody see how I got those or no?
Yes.
Perfect. So that's going to be 8 -24. Feeling good? All right. The limit as x approaches -2 of f of x. We're only going to look at f of x, and then we're going to square it. Looks like that's at -5, right? So we're going to get -5 squared. Careful, make sure you put brackets around this, because if I don't put brackets, I would get -25 as my answer, but this is +25, because I'm squaring the negative as well, right? Because it's the answer to this whole thing is -5, and that whole thing is squared. Does that make sense? Be careful with your parentheses around negatives and exponents, okay? All right, now we're going to do 2 only from the right side of g of x. So 2 only from the right puts me up here at, what is that value? 6. I might zoom in a little more, actually. I think it was 6, no? Yeah, it's at 6. Yeah. So I get the square root of 2 times 6, or the square root of 12. But you're real smart, so you know that's actually 2 square root 3.
I don't remember that.
So could I write it like this? Square root of 12 is a square root of 4 times 3. And then I square root the 4, which is 2. Right? So remember you did those? You simplified radicals? Or you used your calculator, fair enough. All right, we just, hang on, we just did this. 2 from the right of g of x was 6, but let's go find 2 from the right of f of x. So for f of x, 2 from the right is -2. And if I've got -2 over 6, that's really -1/3. For this one here? Because it's approaching this right here when I approach... Wait, I was approaching 2, right? Yeah, 2 from the right. So this is x equals 2. From the right, I'm approaching there, which is -2. Last one, we're approaching -1 from f of x and g of x. F of x, as we approach -1, we already did that. That was the vertex, -6. And then minus, let's find it for g of x. As we approach -1, oh, we did that one too, right? It was -1. -6 minus -1 is what, Emilio?
-5.
There we go. He's got it. All right, can we keep going? Try some hard ones? I know, they're not that much harder. They're just a little bit. Just a little bit. Just a little bit. All right. So if I have a function of g of x and I'm asked for the limit of a bunch of like composite functions, I need to actually work it out. So what I'm going to do is rewrite it. the limit as x approaches 0 of 2 times all of g of x plus g of negative 2. So now I'm just going to plug negative 2 in here. What's negative 2 times 3? Negative 6. Plus 4.
Negative 2. Ah, what? I know.
Wait.
Negative 6 plus 2, guys. It's negative 4. Of course. All over x. Okay? Now, at this point, I have a problem, so we're really hoping that something's going to cancel. So we're going to simplify our numerator and hope that's the case. So we get 6x plus 4 minus 4. Oh, thank God. Because now that 4 and negative 4 canceled. So I get 6x over x, which also cancels. And so, again, remember I said you can draw the line like this, so you don't have to write limit every time. The limit of 6, what's the limit of a constant? The constant. There you go. Look at you guys go. Yep. Guys, when we do this next one, you're going to put a big star on it. It's okay. You'll remember it later and you'll ask.
Why is it important to cancel?
Why did I what, sorry?
Why is it so important to always cancel?
Because if I can't cancel that x on the bottom or the factor on the bottom, it means it's an asymptote and it's going to infinity or negative infinity. And I have to figure out which one. Pablo.
I lost the part where you have to plug in where there's only a G and not G of X.
Well, if this is g of x, doesn't that just mean that this goes into g of x?
Yeah, but what about the G after?
Well, that's g of negative 2. And if I find g of negative 2, that's really 3 times negative 2 plus 2, which is negative 4.
Why do we need a star?
Because this one's super important.
Because it's super hard.
It is a little bit hard, and it's also going to lead into like everything we do for the rest of the year. Not quite, but it's important. So guys, let's work this one out. Okay, so the limit as h approaches 0 of f of x plus h, that's a composition of functions. So everywhere in f of x, I'm going to replace with x plus h. So this would become 2 times x plus h squared minus 3 times x plus h plus 4, because I'm just literally taking these two x's and changing them for x plus h, right? Because composition of functions. Then I'm going to subtract f of x. So I'm going to subtract 2x squared plus 3x minus 4, because if I'm subtracting, I change all the signs. Then I put this entire thing over h. Now remember, in order for this to work, that means I need to get rid of h. Otherwise, it's an asymptote. I am waiting. But thank you for asking.
Can you repeat what you did?
Why did I square? Because if the original function was 2x squared, then it has to become 2x plus h squared. Because this is a composition of functions where x plus h is replacing all the x's. Okay, I can hear enough talking that I think you're ready, so let's keep going. Now remember, you're experts at perfect squares. So this is x squared plus 2xh plus h squared. Or are you so good that you can multiply it by 2?
No.
Okay, we'll wait then. Minus 3x minus 3h. Can we at least cancel these 4s?
Yes.
Right? I don't need to write those. If I'm adding 4 and subtracting 4, let's get rid of those. So that means I'm going to have minus 2x squared plus 3x all over h. I'm getting somewhere slowly. Okay, now I need to multiply that 2 in, distribute the 2. So it's 2x squared plus 4xh plus 2h squared minus 3. Oh, I can cancel the 3x, can't I? Look at that. Negative 3x plus 3x. So I've got minus 3h minus 2x squared all over h. What else can I cancel?
H.
So x squared.
2x squared and negative 2x squared. I can now cancel the h, but I couldn't until now. So let's write it the long way to help you remember how. So the h comes out. That means now I've got 4x plus 2h minus 3. I could not do that until I'd canceled everything else. But now I can pull out this common factor of h, which is fantastic because it cancels with the h on the bottom. Guys, every time you do this, the h will cancel. It has to. If the h doesn't cancel, you did it wrong. Okay, that's the nature of what we're learning here and what this is. And I'm going to go over more what it is in future lessons. But if you see this, the h will always cancel. Okay? So now I'm taking the limit, as h approaches 0, of 4x plus 2h minus 3. Well, that's just going to mean that it's 4x minus 3. Okay? And this here, I know it's an equation, not a number. It's a very important equation. It's literally the equation of the slope of that quadratic. So later you're going to find out that's essentially the derivative. It's this thing called the derivative of this quadratic. It doesn't have to make sense yet. It'll make sense in future lessons, okay? For now, just know that this, while it doesn't look like it, is a slope for a previous equation. Mm-hmm.
We can check everything by doing that derivative, right?
Yeah. All right, so let's put this into a little more practice with a little bit less algebra.
Wait,
A little bit more graphs. Yes, I'm on it.
how did you cancel out the
Because I plugged in h equals 0. Yeah. All right, guys. No, we can do it. Let's go. Consider the 4 exponential graphs below.
No, wait, that's it.
Find the indicated limits for each function based on the graph. All right. How well do you guys remember exponential functions? Ish? How well do you remember exponential functions? So-so, okay. Basically, they always have a horizontal asymptote, and then they go up or down to positive or negative infinity, right? That's what they always do. Always a horizontal asymptote. Why do they always have a horizontal asymptote? Think of a basic function like, say, 2 to the power of x. Can I ever make that 0?
No.
It's impossible, right? The closest I could do is make x a really, really, really small fraction, like 1/millionth. But that's still not going to get me 0. It just means take the millionth root of 2, which is small, but not small enough, right? So my point is, like, that's why they have that horizontal asymptote. That's pre-calc, don't worry.
We only have to look in the graph.
So yeah, for these ones, we're just going to look at the graph for now. Later, we'll do some algebra with it. So I'm going to do, remember, these are left and right end behavior, right? When I go to the extreme left, I'm looking at the left end behavior. In this graph, I go up to infinity. And then I'm looking at the right end behavior. If I go to the extreme right, I level off on an asymptote, which is -2. Me too.
You say, can I go to about
No, you already went once. Like, no, you seriously can't go again. Like, you're not allowed to go twice. No, you cannot go twice in the same period.
what?
No. All right. Extreme left, I get -2. Extreme right, I get infinity. Easy enough so far. Let's look at the next 2 examples. Do you notice here how we have all 4 types of exponential graphs? Right? My 4 types are the 2 forms of exponential growth, which is this or this, and then the 2 forms of exponential decay, which is going to be that one, or, uh-oh, why am I forgetting what the other one looks like? Oh my gosh, no, what did I just do? There we go. It looks like this. There we go. I was like, why is my brain not working? Okay. So if I go to the extreme left on this one, what am I going to? If I go to the extreme right. Extreme left on this one. Extreme right. So, in order to determine a limit as x approaches negative infinity or infinity, in other words, the end behaviors, you have to determine what the graph will look like based on what you've seen above. What are the three possible results? There's only three things we can do. We can go to negative infinity, a constant or a number, which is really our horizontal asymptote, right? That's what it was. Or infinity. Those are our only three options.
Explain the one in the middle.
It goes to a number, and that number is, if you look at all four of them, the number is the horizontal asymptote for all
So the
four.
middle is just saying what possibilities to a number.
Yep, a number which is the asymptote in this case.
Okay.
It will be the asymptote.
Okay.
All right. So our graphs are a, b to the x minus p plus q. That's what an exponential function looks like.
That is a Q. Or
Yep. You might have done h and k. Don't worry about it. A and b are the ones we're going to focus on, okay?
Why is your Q like?
Because it's a lowercase q. Don't make fun of my q.
So weird. It's like a two with a head. Right? Really weird.
Wow.
So that's a two.
No, honey, this is a 2.
No, Mr. Sir. It looks exactly the same. Exactly the same.
I think you guys need to get some glasses. Anyway, all right, I'm going to type these ones so they're nice and clear for you.
Mister, if you want, someone doesn't have to come to one day to your class and hear the lesson brief.
Yeah, they could, but I'm not going to record them forever. This is just because I know there's 2 students that are out for like a couple weeks while they're gallivanting through the States with their older siblings. All right, so the 4 options are A could be less than 0. Now let's start with bigger. I'd rather start with bigger.
We should know that rules like very well.
Yeah. And B could be bigger than 1. No, probably not. You can derive these if you don't remember them. This is exponential growth. Okay? Our next option is that A could be bigger than 0. And B could be between 0 and 1. And this would be exponential decay. I'm going to show you what they look like after. We'll draw them out. Or I could have A is less than 0. And B is greater than 1. This is exponential growth. Oh, sorry, decay. That's decay. And our last example is if they're both negative, or A is greater than 0. Oh, no, sorry, A is less than 0. Getting ahead of myself. And B is between 0 and 1. Then this is exponential growth. And I'll sketch what those look like for you. So if we have A bigger than 0, B bigger than 1, then it gives us growth that looks like this. If I have A bigger than 0 and B between 0 and 1, it looks like
B is
this.
never less than 2.
Impossible. Because think about what would happen, right? It's an exponential function. It would oscillate,
I have a question. Why?
right? Because if it's squared, B would become positive, and if it's odd, it would become negative. So you'd literally have a function that looks like this, with just a bunch of points, and it doesn't work.
Sir,
So-
A and B represent X and Y.
No,
What do they represent?
literally what are right here, A and B. If you remember, A is your starting population, B is your growth rate. Come on, you all took bio. You all took bio. You all took bio. Yeah, you went over this in bio. This is populations. Okay? All right. And then exponential decay. If A is negative and B is greater than 1, then that one looks like this. And if we've got negative and B is between 0 and 1, then that one looks like that. And you'll notice here, let's do it this way. Those and those are reflections of each other.
Mister, can we have a 5-minute break?
Not right now. These are reflections. Okay? All right, let's keep it going. Are you guys ready? Can I keep going now? In this case here, what's A? What is A, guys? First one. A is 1, right? Because there's nothing in front of it, so A is 1. So A equals 1. B is 2/3, so it's between 0 and 1, right? So it should look like this. It doesn't look like that because what does this negative do? Reflects it how? Horizontally or vertically? If it's in front of X, it reflects horizontally because it's in front of X. So it's going to actually look like this. So this is what our graph is going to look like. So now if I go to the extreme right, what am I going to get to? Right, so the limit of this is positive infinity. Make sense? Okay. Now obviously you could do this other ways, but just knowing how exponentials work is sometimes faster. Here, A is going to be -1. B is going to be between 0 and 1 because it's 0.4. And there's no reflection up here. So A is less than 1. B is between 0 and 1. So this one looks like that. And we're going to the extreme left because there's a negative right there. Okay? So this one here is going to be going to what? Negative infinity. What does what represent? Like the -2, the -4? Just moves it up and down. All it's doing is moving it up and down. Yeah. All right, so over here, I got 3 things going on that are important. A is going to be, maybe I'll write it this way. A is -1, so A is less than 0. B is between 0 and 1. And it's reflected. So if I have A is less than 0, B is between 0 and 1, that looks like this normally. But I'm reflecting it, so it's going to look like this. Yep, and because the negative's in front of X, right? So now I'm going to go to the extreme right, and this thing is going to be equal to negative, it doesn't look like negative there. There we go, negative infinity, right? Because this is the one that I'm looking at, and if I go to the extreme right, it plunges down. All right, over here. A is -1. I know it looks like it's -2, it's not. That's what's attached to the exponent. So A is less than 0. B is greater than 1, because B is 2, but it's also reflected. So A is less than 0. B is greater than 1. It's going to look like this. But it's reflected, so now it looks like this. Because there's a negative in front of X, right? And remember, it doesn't matter what kind of function you're looking at, if there's a negative in front of X, it's flipping it. And then I'm going to go to the extreme right. What am I going to get to here? To what? No. I'm going to get to the horizontal asymptote, which is 2. Why is it 2? Because where is the horizontal asymptote normally for an exponential? At 0. And remember I said this number moves it up and down, so we moved it up 2, so the horizontal asymptote's at 2. Does that make sense? All right, next one here. A is greater than 1, because A is greater than 0. B is greater than 1, because it's E, epsilon, which is like 2.7. And it's reflected horizontally. So we got both of them are bigger. Both are on the bigger side. So that's when it's normal exponential growth like this. However, it's reflected. So I'm going off this one here. And I'm going to the extreme left. What am I going to get to? Positive infinity. Yeah.
What number is A?
A is the number in front of the growth rate, which in this case is 1. Because there's nothing there, so it's a 1. For this one, my A is -1, so it's less than 0. My B is once again between 0 and 1, and it's not reflected or anything. So if I look at that, let's see here. I have A is less than 0, and B is between 0 and 1, so it's exponential growth, so it looks like that. So it's going in this way. I'm going to the extreme right, which means I'm going to get to that horizontal asymptote. And what is the horizontal asymptote here? -4, because it would be 0, but then we move the whole graph down 4. You guys getting the hang of it?
Yes.
Good. Because we only got 2 more.
What does it mean? Why it is important?
Like here? It's just writing it properly. Like technically these should all be in parentheses too. Yeah. It's just because what they don't, the reason I would put it in parentheses is because I don't want you to think it's like take the limit and then add 2. Although technically speaking, it doesn't change the answer. So it's not a big deal. All right, now this time I'm not approaching infinity, so what do I do first? I just plug it in unless it's going to be discontinuous, but this is an exponential and exponentials are not discontinuous. So therefore I'm going to get e to the 2 minus 3 plus 2. I'm going to get e to the -1 plus 2, or 1 over e plus 2, or if I really want it to be crazy, I could get 1 plus 2e over e. How did I get that last one? These two should be easy. Like this one should be easy for you to get. This one's not too hard either. Negative exponent. How did I get to this one? Common denominator. I made it 2e over e, which means that it's 1 plus 2e over e. The reason I do that, guys, is because the College Board will sometimes give you questions like that, where they put it as a single fraction, okay? So you need to kind of know how to do it. I mean, you've learned it before, but. All right, now once again here, it's a number, so I can just plug it in, right? So I'm going to get 1/2 to the -2, or +2, minus 3, plus 3. Do you guys see how I got the +2 here? Because it's negative x, and then x is -2.
What is the answer in the 7?
Any of those 3 is the answer to 7. Okay, so then here, this is going to be 1/2 to the -1. I'll put it in parentheses to help us make that make sense. What's 1/2 to the -1? Cross the line, flip the sign. 2, good. 2 plus 3 is 5, right? 1/2 to the -1 just means you flip it and change the sign to +1 as the exponent, which I don't need to write. Right? Like technically, yeah, technically you guys, this is what this is. This is 2 over 1 to the power of 1. That's a really dumb way to write 2. So let's just write 2. Okay? Awesome, guys.